Okay, so I'm sure you're pretty tired of this. I know I am. But fuck it. You know, I'm just gonna keep going until shit is done. You know, my impression is that if I just keep going like this, like eventually, like eventually we'll get to a point where it's done. You know, like this isn't just about like theorizing. This is continuously going until every single little corner of it, of this fucking thing is done, and it's done. Right? We've decided everything. Okay, so where was we at, motherfucker? Okay, I think this was the last slide before. I don't actually remember now. Okay, yeah, I think this is the last slide. Okay, so now I'm getting even more specific. Like, you know, points anchored to space resist movement. Okay, so up until this point, I've got this idea now of saying anchoring, right? So you have a point and you want to just fix its position or fix its rotation, right? Now I'm thinking, well, you could generalize it. Like, why fix the position, right? Why not just have a resistance to movement, right? Or displacement. And then you could have the same thing with rotation. You could just have a number for the point that resists it, right? And if you have an infinite resistance, we could have it between 0 and 1. And if you have infinite resistance, you just set it to 1, and Bob's your uncle, it won't move at all, right? Rotation. Okay, so again, it's not just resistance to rotation in one direction, it's just any rotation, right? Like, this is showing just rotation along an axis, you know, but it doesn't matter. It's like having resistors in both ways for each axis, right? So, and those resistors have equal value, you know, it just resists, no matter what, you know, no matter which way you try and turn it, it's going to resist you. Same with motion. So if you try and move it along this line, like, it's going to pull equally. So it's like a delta value, you know. Like, if it's sitting still it's happy. But the moment you try and move it, it's going to start pulling back, you know. Not necessarily, you know, not necessarily. Oh, so start pulling back. Yeah, so if you put it to a maximum anchoring, yeah, okay, so this is the thing. I'm starting to understand that I'm starting to get to this profound level of simplicity and directness and obviousness. Okay, like, there's two kinds of movements, right? The first is relative to space. So you just have a point, and you're moving it around, and what you want is the point to resist movement, right? Why do you want that? It's like, well, I don't know. It's just one of the things we might want, right? We just might want that. Like, you know, it's just a generalization of the anchoring idea. You know, like, if you say that a certain point must not move, you know, that's saying that it's like stuck to this position, right? And I'm getting confused between moving it in the editor and then having the actual, you know, yeah, having the different points. I mean, okay, so you have this relative motion, which is, you know, if these 2 points, you know, move relative to one another, you want something to happen, right? I guess you could also have relative rotation. Do we need both? See, this is what I'm confused about. For some reason, I find it rather confusing. Like don't they both mean each other? You know, like physically, you get these 2 points, you pull the one, and this, if you pull this guy and this guy resists, it's kind of exactly the same as him resisting to just space, right? To moving at all, right? It's like, why have both? Why have a spring connected to these two and like this constantly updating, creating and dying spring, like connecting this thing to space? Why have both? You know, I mean, in physics terms, it's actually like reality. I mean, this spring constantly just resisting movement, resisting motion is how you model inertia. You know, that's how you do it. It's like a retarding force. There's a retarding force on everything. Like you can push something, and it will push back depending on its mass, right? So it's kind of like generalization of mass. You know, I think, you know, so like if you wanted to never move, you just make its mass infinite. Okay, so let's keep going. I hope this makes more sense. Okay, yes, we are trying to preserve lengths. Yes, why yes? Okay, so relative motion. So what does relative motion mean? It's like, well, at least in our model, like I think you could probably generalize even further, and I hope you I don't know how you feel about me just going nuts with the generalizations, but look, okay, so you have 2 points, and the idea of resisting relative motion is that if you try and pull this guy away, if you try and change this length, there's going to be a force pulling it back, right? So the idea is that you want the length always to be the same. So anytime that the length between them isn't a certain amount, it's going to pull back, right? And I was saying, well, what happens if the length shortens? And I was like, well, if the length shortens, then it should push back, right? So there's 2 things going on, a push and a pull, just depending on a resistance to the length not being this, right? And that's what's funny about it. It's like, with 1 point, it's just the only kind of resistance it can have is with space, but this has got nothing to do with space. You know, these 2 guys can actually rotate around one another, right? Without any resistance, they'll just spin and spin and spin, and nothing will stop them spinning, right? The reason they'll stop spinning is if they're both attached to space, right? That's the only thing that's going to retard the spinning in this case, because the only thing these 2 care about is, you know, the length changing. Okay. So I hope you see that this is getting some fucked up shit. This is becoming like quantum theory. Okay. So the length isn't changing, meaning there's no force if there's motion along the circumference, or if this guy moves along this guy, right? No force. But there is a pull back if the guy tries to move away, and there's a push back if he tries to move closer, right? So it's always going to try and stay here. It's probably going to like oscillate around like this, like just like a fucking electron spinning around. Except that the one thing to notice is that this guy isn't the boss. This guy isn't the boss. It's not this guy floating around here. He's not a neutron, this is an electron. These are both fucking electrons. They both just spin around each other, right? I mean, it's important to, you know, like, I don't know, you know, it's weird. Okay, anyway. Okay, I think we're almost there. Well, okay, so now I'm starting to bring in the front end. I mean, what is the interface going to look like? It's like, well, you're going to have this point, and you're going to have your mouse over here, and you're going to select the point, and then up inside of the window is going to come these 2 sections, which are relative motion and absolute motion. And for each, you have cardinal, and I think Descartes came up with X, Y, Z, I think. Or I think he just came up with X, Y, like 2 perpendicular, there's a proper word, orthogonal axes, you know, that can describe space, X, Y, Z, right? Cardinal, rotation, and then scaling. And all we do is we have a value between 0 and 1 that for each of these you just have a dragger, what the fuck is it called? You know, you can go 0 to 1, and that's it, right? And you do that for relative and absolute motion, and your points, and Bob's your uncle. you've got everything. We've got everything we've described so far. Anchoring, controlling the positions of things. Actually, no, controlling the positions is different. But this is like a complete generalization, not just of anchoring, but of my kind of idea at the beginning of having everything connected with springs. I mean, this is a kind of a mind-warping thing to think about, but I actually don't have a piece of paper for this. This is a new idea I haven't written down. But well, I did think of it before, but I just didn't write it down. Like it's weird. It's like, well, how's this going to control the springs? Because surely if you want to control the springs between two things, you want to select one point, select another, and then control the resistance between them. And this is a simplification of it. It's like saying, no, well, why don't we just, for each point, have a relative, right? So this point, this relative motion here is going to decide the force that's between this and any other guys that are connected to him, right? So it's a weird idea. So you could click on one point, increase his relative cardinal resistance, relative cardinal motion resistance. Wow. And then anytime any of the other points try and move away from him, it's going to struggle, right? Like that, like a complete generalization of it. I mean, the confusing thing is, well, what happens when you have this point here, and then another point here? Yeah, what does fucking rotation mean? That doesn't mean anything. Rotation, what the fuck? Is it really just one line? Maybe it's just one number. Maybe these don't make any sense. What is relative rotation? It's like you don't want the 2 points to... It's like when they move away from each other, it's just one number. It's not even cardinal, right? It's just a length that changes. Like, has anything else changed between 2 points? You know? I mean, you could say relative rotation change, like you could say that you want both points to have the same rotation. But that's weird, right? Maybe you have a rotation distance. Yeah, okay. So it's like the cardinal distance, which is just a number, right? Right, the cardinal distance, which is just x squared plus y squared plus z squared or square root, right? And then you have the rotation distance, which is the same for all the different axes. And then you have... So it's like if you try to rotate one of the points inside of that spring sheet, if you try to rotate it, it's going to really resist you. You know? The cardinal distance hasn't changed. Yeah, the distance hasn't changed. Oh. Fucking hell, man. This is some mad, crazy shit. I hope you appreciate that. Not appreciate me. Appreciate... I hope you think the same. I hope you like... You know, you don't have to say it. I just hope you think it. Anyway. What else? Rotation and scaling, relative scaling. Oh man, this is kind of fucking with me. But it's crazy. Like this could define everything. You know, you still have to actually slot them together. How would that look? Well, see, now I'm just doing what they call... I don't know, there's a special, really boring sounding businessy word for just drawing out, storyboarding everything. Storyboarding is cool because the movie people use that word. Okay, so click in Unity, you say add component block, make our own component, right? I thought about just adding a script, but that's 2 steps. Fuck it, let's just have our own component, right? Add a block, boom, there it is, a block appears, a cube. Right? It assumes you just want a fucking cube, and it puts it down and puts a cube mesh down, and creates a track point sitting right in the center of it. Right? Because where else is it going to be? Okay. Kick ass! Now we got this fucking block. Awesome. Now you press the special button, like a Control Alt or something, and it says, "Ooh, he's trying to." You know, he wants to add shit to this block. So as you mouse over the 2 faces on either side, it highlights them. When you click on one of them, this add button appears in the inspector, right? and you click on add, right? And what happens? Boom! A new block appears adjacent, right? Because this is the functionality for just creating the track as it is. Like, I'm not looking at like 2D or 3D shit, you know. That's what happens. Boom! No new track point gets created inside here. All you've done is created a mesh like this. So now you can move this point around. You can rotate this point. Everything will just rotate with it, right? These two guys are fixed to each other, right? Okay, then you press another new button with like Control Alt Shift or something, and then it says, ooh, it looks like he's trying to create a track point. So it highlights all the places where you could put a track point down, and I didn't want to draw these dots everywhere because it would be all over this whole fucking thing. This whole thing will be chicken pocked, you know? I mean, maybe that would be a little bit overwhelming having all these dots highlighted everywhere, like, but you'd want that, you know? You want to be able to select it here in the middle of this block, in the middle of these two lines, you know? I mean, you know, those are the places I'd expect. Anyway, so you press these special key combinations, these things appear. If you mouse over them, they highlight, and when you click on them, boom, it creates a new one. You know, actually you shouldn't have to click on new, fuck that. You just click on it and it appears, and it selects it. It creates it and selects it and shows in the inspector, and there it is, and you can anchor. You can just click anchor, boom, right? You just click a tick box that says anchor completely, anchor this completely, and there you've done it. You've done it in 3 steps. You do the mouse, the keyboard combination, which highlights everything. You mouse over it, right? And then you mouse over and click, and then you click on, or maybe we even use a keyboard shortcut to select maximum cardinal anchoring, and then another one for maximum rotational anchoring, right? And it's all just options. And Bob's your uncle. Bob is your fucking uncle. That does everything. That's it. That should do the track as we have it. Like, and then for each block, obviously you click on another keyboard combination, and then you click on the block or something, and then it allows you to, you know, assign the block type, you know, or give the block a mesh, you know. Yeah, that's at the moment all we've got. Oh, and to assign 2 different kinds of meshes, the visual and the physical. But at the moment, that's all we need. We just need something that will create this block, put it down, the track points inside of it, and then an option that allows you to just add blocks to either side, right? And then an option that allows you to anchor. And that, my friend, is everything. That will encompass the functionality we have now, times 1,000. Like, you know, not times 1,000. I mean, you know, everything that we can do now, we'll be able to do it, but just gorgeously and in totality. I don't think there's any. The one thing I haven't talked about is how are we going to create this. You know, at the moment we can still only click on. No, dude, this is controlling. Oh, this doesn't make sense actually. No, it doesn't make sense. Okay, I've made a mistake here. Okay, so these outside points are, yeah, these outside points aren't going to be here. You know, it's just going to be this guy, this one in the center here, center here, center here, center here, right? Because we're talking about just this 1D thing. This guy assumes 2D. This assumes 3D. Yeah. This assumes 3D. If it was 2D, it would also be back here. Yeah. Okay. So it's just these points inside the middle that get highlighted. These 2D things, I mean, that's a whole other kettle of fish. Whole other kettle of fish. Yeah, okay. So my bad, you highlight, it's just these inner points here that get highlighted. Yeah. You can twist it, you can rotate, you can add bits to it, you know, yeah. Yeah, that'll be fucking amazing. Alright? And I guess all of these track points are just going to be components inside of our block, right? So you create a block, maybe, you know, you want to call it block manager, but no. That's not what happens. Yeah. So you just create a block, right? And then this button creates a new block, so it's a new block. Okay? It's just another game object, right? Now this track point, the fact that this track point exists is just an option inside of this block. It's not another object. Okay? I mean I mean, if you want to control this track point, sure, you click on it and you can move it, but it's not, I don't know, it's weird. It's like, if you're going to save this block out, if you want to save this out, I mean, you can save out all the blocks, yeah, but, you know, they're all just, it's all just blocks, right? That's all that this thing describes, a bunch of blocks. The fact that this block has a track point, that this internal possible track point of this block is enabled, is just, you know, it's just a happenstance. Like, it could be a standard. Each block has 3 possible track points. 1, 2, 3, right? That's it. And when you activate this one, it just creates, it activates it in this guy and in this guy, right? You see what I mean? So there are no track point objects. It's just that this block has decided to assign a non-zero. This block's okay. Okay, this block has 3. What does it have? It has 3 motion settings, right? Beginning, middle, and end, right? Its beginning motion setting has a motion setting. A motion setting comes in 2 parts, which are relative and absolute. And both of those settings have cardinal, rotation, and scaling components to them, right? So it's literally just a struct, and I think we should use structs, please. No more lists, no more like just random using arrays. You know, I'm really worried about performance now. I'm starting to get paranoid that, you know, looking at how slow it is now, dude. Yes, we got work to do. But okay, so yeah, so it's just got beginning, middle, end, I think, or maybe naught. How about naught minus 1 plus 1 or something like that? I don't know. What else? And each one has just a retardation value, and it starts out being, yeah, the absolute retardation is, oh, that's it. That's all a block has to be, you know? Beginning, middle, end. Retardation values for absolute and relative motion, with motion components of cardinal, and these are all floats. The cardinal motion retardation it's literally just a float, right, between 0 and 1, whereas 1 means it's not gonna fucking move, right? And what it's gonna fucking move is like if you apply a force to it, like of course, if we set it to 1 and we try and move it in the editor, I don't know if we should be able to move it. I don't know. Like, because my impression was that we're creating this like physicsy system, and then when you're in there trying to move the points yourself, it's just like you apply a force to it. You know, it's not like you actually move it, you're applying a force, right? And if you set it to 1, it doesn't matter how big the force is, it's not going to move. So I don't know how that's going to pan out. But yeah, so it's literally, amazingly, incredibly, it's just these 3 values that you set, right? And it would be nice if you could like mouse over one of the values, click, and then click on it to assign it. You know, you could have some nice keyboard shortcuts to just fix points down. Another keyboard shortcut to just rotate, to just select a point and then start rotating around it. So we could twist. I mean, this could become a fucking kick-ass editor where you just click, moving and just bending this motherfucker. You know, and you know, yeah. So the geometry of it, I think this sorts it all out. This sorts out that fucking problem one time. One time. It's still not completely done. Like, what happens with, what about these outside points? Obviously, how the fuck is this going to be done? Like, when you create a new block, we have to step through all of that shit. Okay, we create a new block. It creates a new game object. That game object has a what is that game object? It's like, well, it's just a sibling, right? And it just happens to be next to the sibling, so it gets drawn next to it, no matter what. Remember, no matter what we do, this face between these two blocks is always going to be connected. If we go with this block approach, I'm hoping that we can just use blocks to do whatever we want. Like, even though the track might not look like a block, at least they're stuck together like blocks. Like Lego. Yeah, what else? Whew. Yeah, I'm tired now. I feel like I've just blown my load over and over again, now I'm just finished. Now I'm supposed to go to this damn party with all my best friends. Ooh. What's going on? Oh, I can play Half-Life now. Yeah, it'll be fun. I just want to keep going, man. I want to keep going until this is fucking done. Because can you imagine, like, once this is done, it's gonna be banging. Like I said, like, it's just this very basic thing that we've done. We created this magic block. But maybe you're right. Maybe we do need like a parent object. Maybe when you create a block component, what it does is it creates a main game object and then creates a child, this guy, right? And it activates this dude in the middle, right? And then when you want a new one, you can create it on the parent. You can click on this interface. There's several ways of doing it, but it just creates a new one on the side. Bam, and it literally is just another one on the list. So inside of the parent object is just block 1, block 2, block 3, block 4. Block 1, block 2, block 3, block 4. And depending on the order in which they're listed, that's how they're connected. That's all we need in order to do this. Like, there's nothing else defining. And then all each block does is it defines whether or not any of these any of the motion in the block is what if the retardation value is non-zero, is positive, right? Like, that's it. But if not, then then the block does nothing. Then you just add another one, add another one, add another one, and then this block could suddenly put a value down, and that's the only data type that we need. I mean, I hope you appreciate that. Like, I hope you recognize that you see what I mean. Like, it's that it's remarkably basic. Like it's literally just these two things, like retarding two different kinds of motion for points inside of it, and that's it. That defines all the deformation, the structure, the connectedness, the pathing, doing complicated twisting and motion. It's like, because the way we have it right now, it seems very, very complicated. Like, there's all these different classes and types, and you've got a game track point, we've got the track points, we've got the Hermite function, we've got the Hermite utility function, which has the formula. Then we have another one that gives the entire path. Then we have another one that kind of takes blocks and meshes them along the path. I'm saying we don't need any of that. And everything has got this track points array, and we don't need any of that. Like, we don't need we don't need a main game loop. We don't, right? This thing should draw itself. Like, there's no reason for the main game loop. We don't need it to be attached to any other script. We don't need another script to go along and tie it and all of its functions together, right? It has an await function. It has a start function, which, by the way, you know, have different executing paths, and I don't really understand why there's both. And then there's update per frame, which is the physics one. There's a lot of other ones actually that I don't know about. Like there's a pause one as well, I think. But yeah, so all this thing does is it's a singular script, right? Which there's two scripts, right? There's the block manager and then the block script, right? All the block script has inside of it are these, all the block script has to have are these retardation values, and it initializes everything to 0. So you've got your first you have the motion. It's like a struct which is motion retardation, right? And in that struct is 3 floats, which is cardinal, rotation, and scaling, right? Three values that are inside of the struct. I know we could probably just tie it to a game object because it's the same thing. Not really though. I mean, okay, it's not. They're all scalar. And I don't like tying things to game objects. I think we're really going to start kind of paring down and being more, more kind of performance conscious. If this is going to work, if you're psyched about this like I am, about what I'm talking about, like this could be really cool. Like I think it's only going to work if we're if we start kind of becoming more conscious of performance. Okay, so you have the struct, 3 floats, cardinal, rotation, scaling. Then you have 2 instances of those structs, one called absolute, another one called relative, right? And that's it. That is all that is inside of block.cs, right? That's it. No, that's not true. Okay. Okay, yeah, okay, then you have a struct of, motion, I just realized that the motion retardation itself is 3 values. It could be, x prime and x double prime. It could be displacement, velocity, and acceleration. I mean, I think the 3 is like, for some reason, that's what people use. 3 of them. Okay. So there's a struct called motion retardation, and it has 3 floats: displacement, velocity, acceleration, right? So it's the displacement, retardation, the displacement, motion, retardation, velocity, motion, retardation, or no, just displacement, retardation. Okay, so you have a struct called retardation. One is called displacement, the other one is called velocity, and the other one is called acceleration, right? Retardation. Then you have something called motion retardation, and it has 3 of these retardation structs in it. It has the what does it have? It has cardinal, it has rotation, and scaling, right? Those three types of retardation, and this defines the motion retardation struct. And then finally you have two instances of these structs, and that is absolute and relative, right? Okay. No. Not yet. Okay, not yet. I need to take the fuck off. Okay, what do we got? Oh yeah, we have to decide on. Okay, these three places in which you could define this, like on this point. Like there's the back, middle, and front. You know. Yeah, let's just do it like that: back, middle, and front, because you add them, and when you add them, you know. But the problem is you can add it on either side, but whatever. You just say left to right, right? So okay. Calling it back, middle, and front. Okay, so you have a point, right? And the point has two types of motion retardation, right? One called absolute and one called relative, right? And you have back, middle, and front, and they're both points, right? So that's what's inside block.cs. Block.cs first starts out by saying that there are 3 points. One called back, one called middle, one called front. Right? Now if you look at the definition of a point, you see that it's a struct that has two variables, one motion retardation variable called absolute, and then another motion retardation variable called relative. Then if you look at motion retardation, you find out it's a struct, and it has, what does it have? It has 3 retardation values. One is, fucking hell, one is, come on, I'm almost there. One is cardinal, the other one is rotation, and the other one is scaling. Okay, then if you look at retardation, finally you get to the bottom, the leaf node. It has 3 floats called displacement, velocity, and acceleration. Boom. Hey? Boom, boom, boom. That is what defines a fucking block. And there's nothing else, I think. What about its position? Well, the block has an XYZ. Yeah, it has a transform. Oh, thank God. Fuck. No, but even then, you know, you could move the block around. If it has no retardation on it, like, then it's not going to do anything. Right? It doesn't give a fuck. Like, the position doesn't matter. You know? Shit. So confusing. Okay, I think this thing's gone along long enough. Ugh. But that, I'm pretty sure that that's all we need. Right? And then you have this manager script. So it's just those 2 scripts. Just that one, the block, and then the manager script. And the manager script looks at any child game objects, checks to see if any of them have a block script attached to it. If so, it creates this fucking thing in order. Right? Okay, and then before we get into what else it does, how it actually bends everything, you know, we also got to remember that we want to be able to click on this guy and delete it. But the beauty of it is that you just fucking delete it. You just click on the game object and you click delete, and bam, it dies. And then it's assumed, because this other one is sitting up over here, it just drops this guy and then these two guys are connected. I mean, it's magic, right? We've got all this functionality already. If we want to insert something here, we could, if we wanted to, make this complicated thing that highlights this. I mean, it'll be nice. But, I mean, given the model that I've described, all you have to do is just copy this guy literally inside of Unity. You just click on the sub-child and you click on him and you Control-C, Control-V and then drag him and you will drag him and make sure that file appears between these two. Magic, right? It's 6 o'clock. Okay, well, I'm going to save this. It's going to take forever to upload it.